Now, related to the variance swap, we also have volatility swap. Actually, volatility swap is actually more traded. So the volatility swap has a payoffs very similar, but instead of calculating variance, we're looking at the realized vol minus some set value of vol. And the realized vol is calculated this way, okay? So we're taking the square root here. And so essentially, as still the price of the asset that a particular variance swap, a particular variance is calculated, then you take the square root of that, you get the vol. The value of the volatility swap is then this. So here, instead of the expected variance, you have the expected vol. So the important notion here is that instead of we have to use what we have learned on the variance swap to be able to calculate what is this expected realized vol. This expectation is again taken under the risk neutral probability. Now to do that, we know that the realized vol is really equal to this. So this multiple is basically square root of V bar, which is basically sigma bar. Then we can take the Taylor's expansion for the second term for the second term at 0. Then we essentially have this. So now so this is the first term. So if we take this Taylor's theory expansion only on the second term at around 0. So this part will be 1 plus this thing here. And if we now take expectation of this thing, this part remains unchanged. And we carry this through 1 is 1. And this part will become 0 because expected this minus expected this will be 0. So this will drop out. Then you come over here, you'll see this becomes variance of the variance and the expected variance square. So we actually have a variance of the variance. Now, once we've done that, we are able to calculate the value of the volatility swap because we know we have an expression for this, which involves the variance of the variance. So let's take a look at an example here. So we have a volatility swap, which is again 3 months, and once I will receive 3 months realized vol and pay 23% volatility on a notion of 100 million. So we have this the standard deviation of the average variance is 1%, and so this part is related to the variance of the variance, and the risk-free rate is at 4%, and dividend yield is 1%. Reference asset is traded again at 1,020. So we have a whole bunch of implied vols and at the different strikes that give us the option prices. So we can calculate the volatility swap. So we know the expected variance is this, which we calculated in the earlier example. And so the expected value of the vol is really square root of this expected variance that we know. And here is the variance of the variance, which is 1% the volatility of the variance square. And this is expected V bar. And when we put everything in, we have this 24.84%. So and then the volatility swap will have a value of 1.82 for the side that is receiving the realized vol but paying 23%. Now the difficulty here related to this volatility swap is that one has to calculate the variance of variance, or the volatility of variance, which is a very difficult number to get precisely. Typically, it's difficult to estimate this value here. So we'll conclude our lecture on pricing swaps. Swap is a very flexible financial instrument. You can design all sorts of different ones, and we just had a sample of a number of them, but there are hundreds and hundreds of different variations you can have. So we're not going to belabor on each of them, but essentially we have tools that we have built up over the past few lectures to allow us to effectively calculate the value of a lot of those swaps. And in principle, a lot of time, the way to calculate a financial asset are essentially two. Number one, the easier one is that if you have a financial asset, it calls a particular name and has a payoff structure, but you look at it and say, okay, I can actually change this payoff structure. Well, based on this payoff structure, this particular asset is actually a portfolio of some other asset that we recognize and we know how to price. Then the pricing of this particular financial asset will then be transformed into pricing a portfolio of related assets. And as soon as we are those components are priced, we add them together, we'll get the price of this new financial asset. Now, the other way to look at that is sometimes we can use the equivalent martingale approach to set up a certain condition. And we find there are market observable values that are expectations that we need. So once that is okay, we can substitute the expectation with the market observable values, and then we're able to calculate it. So it's really those two principles that we're using to allow us to price financial assets. Now, next lecture, we're gonna look at how we're gonna price some of the exotic or complex options.